Today we are starting chapter 7. 7.1 is about ratios and proportions. This really should all be a review. It's not very geometry heavy yet today. This is more of an algebra based review. A ratio is a comparison of a number A and a number B using division. So this is not a typo. We're calling the first number A, the second number B. Comparing two numbers using division. A ratio of A to B can be written in three ways. The first way as a fraction. It would look like A over B with a fraction bar. Second way is with a colon, A colon B. And the third way is with words to just write out A to B. Usually when we write ratios, we tend to prefer fractions, but any of these ways are correct. Also, when we write them, usually A and B will be numbers, not letters. We'll be comparing two numbers. In a ratio, the units must be the same. You may need to convert units to make that happen. A ratio must also be written in simplest form. Even if it's not written like a fraction, we need to reduce them every time it's possible. In this chart, we've got commonly used conversions. Some of these you probably already know, like 1 foot is equal to 12 inches. 1 yard is equal to 3 feet. Does anybody remember how many feet are in a mile? You're off by a little bit. 5,280. There are 8 ounces in a cup, 16 ounces in a pound. Does anybody know how many centimeters are in a meter? 100. Good. Centi means 100. What about meters in a kilometer? 1,000. Very good. And how many quarts are in a gallon? 4. So these are just some helpful conversions. There are other ones that we might need at some points. You'll see that later. But these are some common ones. If you're not familiar with them, I would keep this handy. So on our examples, we are going to simplify the ratios. Notice that some of these are written as fractions, some of them are written with colons. That's fine, we can simplify them either way. When we are simplifying ratios, we need to make sure that the units match first before we start trying to change them. So on number 1, do our units match? Yes, they're both centimeters. So we just need to simplify 60 to 200. If it helps you to visualize it as a fraction, you can rewrite it off to the side as a fraction. Your final answer should technically look like the original problem, meaning that we should use a colon in our answer. But if it helps you to think about how to simplify this as a fraction, you can write it that way. Just make sure the first number goes in the numerator on top. The second number goes in the denominator in the bottom. Who can tell me how we can simplify 60 to 200? Keon?
Just count off the zeros.
So that's part of the way we could do it. So we can cross off those zeros, and we're left with 6 over 20. That helps us out a lot. But we can still simplify both of those by dividing by what? 2. What's 6 divided by 2?
3.
So we have 3 centimeters to 20 divided by 2 would be 10 centimeters. And that would be our answer. That's a simplified version of that ratio. On number 2, any thoughts on what we should do first? Angel? Good. We have to convert our units because we need our units to be the same. Right now, they are not. We've got feet on top, inches on bottom. What unit do we want to stick with? Inches is going to be easier for us. It's going to be easier to turn 3 feet into inches.
36.
Good. We multiply by 12. 3 times 12 gives us 36 inches. The 18 can stay because it's already in inches. Now that we've got them both as inches, we can simplify. Keon?
You can divide them both by 18.
Good. What is 36 divided by 18?
2.
2, and 18 divided by 18 is 1. Now I would put a star by this, circle it, something. If you don't put the 1 in the denominator, if you just write it as 2, you're going to get it marked wrong. These are ratios, which means it's a comparison of 2 numbers, which means I need to see both of the numbers. Okay, so normally when we would see this as a fraction, we would say, oh, it's just equal to 2. We don't have to put the denominator. And most of the time, that's fine. But not with ratios. With ratios, we need both numbers there. For your notebook quiz, it is recommended to have the original problem to get all your points. Other questions before we continue on to number 3? All right. Again, if it helps you to visualize it as a fraction instead of using a colon, you can write it as 35 over 700 for now. What is something that both of those are divisible by? 5. Okay, they're both divisible by 5, so we could start there. They're also both divisible by 7, if you'd rather start there. So let's start with 7 and just see where that gets us. If we take 35 divided by 7, what do we get? 5. And if we take 700 divided by 7, what do we get? 100. Can it be simplified more? Yes. Now they can both be divided by 5. 5 divided by 5 is 1. And 100 divided by 5 is 20. Notice that when I switch between fractions and a colon, the number on top goes with the number in the front. The number on bottom goes with the number in the back. So if you're going to switch between fractions and colons, you have to keep those straight. Don't switch it around and think that this is 20 over 1. That's a different ratio. All right, number 4. First thing we need is to make sure our units are the same. Are they the same? No, so that's a problem for us. We have feet and yards. I'm going to recommend we stick with feet. Technically, you could change the top into yards if you'd rather on this one, and it wouldn't be a huge deal, but... Well, we've got 12 feet on the top. How many feet are in 1 yard? 3. So we're going to take 5 times 3 and get 15 feet. Now we are able to simplify. Both 12 and 15 are divisible by 3. So 12 divided by 3 is 4 feet. 2. 5 feet. If you'd converted your feet into yards in the beginning, you would end up with a similar ratio. Just your units would be different. So on some of these, there can be more than one correct answer, depending on what units you stick with. So we've got 3 pounds to 4 ounces. Those units are not the same, so we need to change one of them. It's going to be best if we change pounds into ounces. So what am I going to be multiplying the 3 by? 16. So times 16 gives us how many ounces? 48, good. So we have 48 ounces compared to 4 ounces. Both of those numbers are divisible by 4. 48 divided by 4 gives us 12 ounces. 4 divided by 4 is 1 ounce. Good. Remember, don't leave off the 1. Questions about number 5?
Yeah, I have a question.
What's up? On number 6, our units are different. We want them to be the same. We need to stick with months. How many months are in 2 years? 24, good. 24 months compared to 10 months. Both of those numbers are divisible by 2. 24 divided by 2 is, so we've got 12 months compared to 5 months. Make sure that you are converting your units before you simplify. If you simplify first, it might not work out right. So this problem says that the lengths of A to B and B to C are in the ratio of 4 to 1. The whole segment measures 30. So if you want to mark that in the diagram, you can. And we are asked to find the lengths of AB and BC. When we do problems like this, we need these segment lengths, A, B, and BC, to be kept in the ratio of 4 to 1. So for example, the side lengths could be 8 and 2, because 8 compared to 2 would reduce to 4 to 1. Okay, right? 8 to 2 would reduce to 4 to 1. But is 8 plus 2 going to add up to 30? No. So it can't be 8 and 2. It also is not going to be 4 and 1. So it's our job to figure out what those side lengths would have to be so that they add up to 30 and their ratio is 4 to 1. Keon?
28 and 2.
28 and 2 would not work because the ratio 28 to 2 would reduce down to being 14 to 1. Right? So that one's not going to work. That one does add up to 30 though. So what happens on this, you'll notice that on your worksheet notes here, there's a spot for an equation. It helps if we set this up algebraically. We know that in order for it to stay in ratio, if we multiply 4 and 1 by the same thing, like by an x, that they'll stay in the ratio of 4 to 1. So if we multiply both 4 and 1 by the same number, this will work out. We've already talked about if we add these two pieces together, it has to add up to what? 30. So if I set it up this way, I can take 4x plus 1x and set it equal to 30. And that way I can figure out what I need to multiply both the 4 and the 1 by. So here's our equation. To solve it, what do? Combine like terms, add the x's. How many x's do we have? 5 of them. To get x by itself, we are going to divide by 5. We get x equals. But that's not our final answer. What we wanted to do is find the lengths of A, B, and BC. So if x is equal to 6, what's the length of AB? Not 6, 24. AB was equal to 4x. That's 4 times 6, which is 24. What's the length of BC? Okay, BC is just going to be 6. It was just equal to 1x or 6. So AB was 24, BC was 6. If we add those together, we do get 30. On number 8, the perimeter of a rectangle is 80 feet. The ratio of the length to the width is 7:3. Find the actual length and width of the rectangle. We don't need a picture for this one, but it does help us to have one. So if we have a rectangle, we can measure the length is 7 to the width is 3. But what do you think? I'm not just going to put a 7 and a 3. What am I going to put with those? An x. So I don't know the whole length of it, but I know if I compare them, the ratio is 7:3. So for now, I can call them 7x and 3x. Now for the equation part, we need to use the equation for perimeter. Does anyone know how you calculate the perimeter of a rectangle? Kian?
Add them all together.
We add up all the sides. So traditionally we say we take 2 times the length plus 2 times the width, and that gives us our perimeter. So now we can start plugging things in. We know a number for the perimeter. What is it? 80 equals 2 times the length. Well, what do we have the length labeled as right now? 7x. Plus 2 times the width. What did we label the width? 3x. And now it's just a matter of using our Algebra 1 skills to solve this. 2 times 7x is 14x. 2 times 3x is 6x. If I add all my x's together, what do I get? 20x. So I'm going to take away the problem so I can keep solving it. So we have 80 equals 20x. To finish solving for x, we are going to divide by 20. What do we get for x? X equals 4. Okay, but I didn't just want to know what x equals. I want to know what the length and the width are. So in this case, the length we represented with 7x. So we take 7 times 4 and we get 28. What are our units? Feet. Good. If the problem gives you units, I expect you to use them. And our width was represented by 3x. So when we plug in that 4, what do we get? 12 feet. Wonderful. So we found our length and our width. The other thing we need to talk about today are proportions. A proportion is an equation that states 2 ratios are equal. When we write proportions, our ratios are written as fractions. If we have it set up the same way they do here with A over B equal to C over D, that's what is meant to go on that big line kind of in the middle of your notes there. We would call B and C the means. A and D are called the extremes. As many of you hopefully remember and know, to solve a proportion, you cross multiply. So that means the product of the means, b times c, is equal to the product of the extremes, a times d. So if you want to write that at the bottom, b times c is equal to a times d. That is how we solve proportions. We've got 4 examples with proportions. The first couple, I hope, are pretty straightforward. The last 2 can get a little tricky sometimes. So on number 9, we have to cross multiply. That means we are going to take 3 times what? 8 and set it equal to 6 times x. I will not necessarily require this step here. Okay, I know most of you probably can take 3 times 8 and just write it down because you know 3 times 8 equals 24, and 6 times x we just write as 6x. Okay, I do expect to see this step here. That one is the one where I would definitely need to see your work. And then what would we do to both sides? Divide by 6 and we get x equals 4. If you don't show the divide by 6 part, that's fine. Okay, I know that was like an algebra 1 thing. We're moving past that a little bit. That doesn't mean you don't show any work. That just means I don't require as much work as if you were in my algebra 1 class. So on number 10, we're going to multiply 5 times x. 5 times x is 5x. We set it equal to 3 times. What does 3 get multiplied by? 45. What's 3 times 45? 135. And then to get x alone, we are going to divide by 5. What do we get for x? 27. Again, if you didn't show the divide by 5 step, it's okay. Not a big deal. I do expect to see the 5x equals 135. All right, number 11, things get just a little bit more interesting. We are going to take 5 and multiply it by 6. That gives us 30. We are taking 3 and multiplying it by y plus 2. So on problems like this, we might show a little bit more work because there's more work to do. You're not just multiplying it to the y. You're not just multiplying it to the 2. You have to, what's that special word when we multiply into parentheses? Distribute. That 3 gets distributed into the parentheses. So we have 30 equals 3y plus 6. Beautiful. Questions about why this one is different? Hopefully we can see from the original problem how it looks different from the first 2 that we did. And now that means we are going to also have a couple extra steps to solve it. First thing I should do, subtract the 6. So if we take 30 minus 6, we get 24 equals 3y. And then divide by 3, y equals 8. So we had to subtract 6, divide by 3. I was running out of room, so I didn't show those written out. If you do write them out, that's fine. All right, on number 12, I'm taking m plus 2 and I'm multiplying it by 10. Okay, so I'm going to write that as 10 parentheses m plus 2 so that I remember to distribute. And then I have to take 5 times 14, which gives me 70. When we distribute the 10, what does that give us? 10m plus 20 equals 70. To get m alone, Subtract 20, that gives us 10m equals 50, and then we would divide by 10, so m equals 5. And that is the end of today's notes.